What's going on, everybody? James here from Artificial Entertainment, and welcome to another episode of AI in Unreal. And in this one, we're going to be looking at adding the perception system, as well as talking a little bit about base states and substates. So let's go ahead and dive in. So I have here the folder that we've made in the last video, however I just kind of cleaned things up a little bit in the content browser. Now, to talk about base states and substates, I kind of want to start there. So a base state is essentially the primary action that is being controlled within the behavior tree. So if I go ahead and pull up the behavior tree that we made in the last video, you'll see that we have patrol being as our primary behavior, but a secondary branch going down for random idle behavior when he's moved to his patrol location and engaged the cooldown. What this means is that patrol is our base state and the random idolized behavior are a substate that happens because this is not going to execute when we're not in the patrol state. So these are things that are going to be something to keep in mind, is that when you're creating states, you can create your main state and actions within those and then create additional substates. But what if you wanted to make additional base states for your AI's tree? How would you go about doing that? Well, it's actually very, very easy. Now, we're going to need to set up a couple of things to make this functionable, but first thing we're going to look at is taking our patrol behavior and putting it into its own behavior tree. So we're going to minimize this, and we're going to go and right click, and we're going to go artificial intelligence and click on behavior tree. This is going to be patrol underscore BT. Now, if we go back to our main AI, highlight the entirety of our patrol, so this entire system here except for the selector, and then control X, so this way we can cut it out. Go back to our patrol behavior tree that we just made, and then control V. This way it'll put all of our patrol behavior inside of that new behavior system. Now the cool thing is that because we only have one Blackboard, it's automatically going to assign that Blackboard to this behavior tree, so we don't really have to do much. Now we can go back to our main behavior tree, go off of the selector, run another selector, and then off of this, we're going to run down and do a run behavior. And then the behavior we're going to run from the behavior asset under the details panel is just going to be that patrol behavior. So now what will happen is that this entire system that we made for the patrol is now just in this one little node. Now again, talking about the differences in the different state styles, you also want a way to be able to easily control the influence of what is happening based off of the active state. And the easiest way to do this is realistically through enumerations. But we're not going to use them right away, but we'll go ahead and create a base state enumeration so we have it. So we're just going to right click, we're going to go to blueprints, and then click on enumeration. What we're going to do is we're going to name this base state underscore enum. Now for those of you who don't know what an enumeration is, it's essentially just a named piece of data that you can use to switch in between for different states. I have a better explanation on enumerations, and I will leave a link to that in the bottom of this video. But once you have your enumeration made, we can double click, open it up, and you'll get this. What we can do to add some information to this is at the top, you'll see Add Enumerator. We're going to click this twice and go down to where it says Display Name under the enumerators. These are our two new enumerators. So what we're going to do is under enumerator 0, we're going to take this and name this to patrol. And then enumerator 1, we're going to take this and name this to combat. This way we have a patrol state and a combat state as well. These are going to be individual from each other, and this is why we want to create the enumeration to allow us to easily swap between the two states. So we can go ahead and just save that and go back to our main behavior tree. We're going to go up to the Blackboard up at the top corner, and we're going to add that enumeration into our Blackboard. So what we're going to do is go to New Key, and then click on enum, and then we're going to name this base state, and then we're going to go over to the Blackboard details under key type, click the little drop down menu, and then under enum type, switch it from none to that base state enum that we just made. Go ahead and save that, and there we go. Now we have our base state enum added into our behavior tree. So now what we need to do is we need to start making our perception system. So there's a few things we're going to need to set up first. We're going to go to the third person, blueprints, BP third person character, or whatever character type you're using. If it's first, third, custom, whatever. Just go to your character, and we're going to go under the BP third person self, and then under the component section, we're going to click on add, and then click on AI perception stimuli source. And now with this highlighted, under the details panel, we can add some things for our character to register as for a source when it comes to certain AI perception stimulation. So under the AI perception section here, we can go as register as source for senses, and we're going to add some array elements. So we're going to add elements here, and under index 0, we're going to switch it from none to AI sense hearing. And we're going to do this again and switch this time to AI sense sight. Now we are going to make some adjustments, but we're going to do this inside of the controller. So we're going to minimize all of this and we're going to go to our AI controller now. So we'll go AI assets and bring up the controller. Now I'll pull up the event graph here just so we can see everything, but we don't really need it. What we're going to do is from the components tab, we're going to go add and we're going to go AI perception. So this is going to be the actual perception system for our AI. And what we're going to want to do is under AI perception, under the census configuration, we're going to do the same thing, or census config, is we're going to go add element under the dropdown, and then we're going to select AI sight, and then do it again for AI hearing. It doesn't matter if they're in the same order, it just matters whether or not you have the right configuration for the sight. So if you have sight on one and hearing on another, they're not going to register properly. So make sure that if you're using sight on both and hearing on both, that you have those properly applied. Now, once you have those added in though, we can click these little drop downs here, open up the Sense menu, and the first thing we're going to go to is Detection by Affiliation. By default, Unreal Engine classifies everything as neutrals, so you can just select neutrals and be fine, or you can select everything. I like to select everything, but you don't have to. And the other thing we want to do is make sure to select the max age, set it to 1. This way it'll actually forget the data if we decide to make it forget said data. However, if it's 0, it will always remember the data and never reset itself. So something to keep in mind when using the perception system. Now we're going to need to go and do the same thing under the hearing configuration. So we're going to use these drop downs, go Detection by Affiliation, check all these boxes, and then under max age, set it to 1. So now that we have this in place, we're going to actually make our perception component piece now. Now, a lot of you might be wondering, well, I just closed the controller. Why would I do that? Well, we're not making our AI perception system through the events inside of the controller. We're actually going to make our perception system work off of the EQS, or Environmental Query System. Now, for those of you who don't know, EQS is basically a way to detect through a series of different types of detection. It can be by range, perception system. It can also be done by just generating an array of actors around and seeing if it hits anything. There's a lot of different ways you can use for the EQS. But what we're going to do is we're going to right click, make a new folder, and we're going to call this EQS, so this way we can have a nice folder for it, and then we'll double click and open it up. Now to make an EQS, now these are just going to be referencing object or location data. That's all it does. It does not allow you to be able to set anything other than object and location data within the Blackboard, so keep this in mind. But we're going to go ahead and right click, we're going to go to Artificial Intelligence, and then we're going to click on Environment Query. This one we're going to name as Hearing Perception EQS. And then we're going to double click, open it up. And as you can see, when you open it up, it's going to look very similar to a behavior tree. However, if we pull off the root, we're not going to get the same composites and tasks. We're going to instead get generators. These generators are used to be able to actually create the detection that you want. For example, you can create points around in a certain style of shape. You can create it in circle or a cone, donut, grid, path and grid. You can also use the current location. You can use composites. You can also generate actors of class. But the main one we want here is going to be perceived actors. So we're going to click on this and we're going to open this up, and then we're going to work on the details panel here a little bit, change some information. So the first thing we're going to do is under allowed actor class, we're going to change it from none to BP third person character, or whatever character class that you're using. We're going to keep the listener context to querier. However, the sense to use, we're going to change this from none to hearing. Now, none by default is going to act as a perception for all senses. So if you can do hearing and sight and everything all in one, I like to separate them out though, because this way I can set certain values depending on what sense is actually being used. So now that we have this perception EQS, we're going to right click back in the content browser here, and we're going to make another EQS. So we're going to go Artificial Intelligence, Environment Query, and this one is going to be Sight Perception EQS. Now we're going to double click, open this up, and off of the root, we're going to do the same thing. We're going to go Perceived Actors, but this time sense to use is going to be AI Sense Sight, and we're going to do the same thing where it's the BP third person character, or whatever your character type is. Once you have that, save it again, minimize, and we are good to go. We now have our EQSs in place. So what we're going to do is go to our AI main blue behavior tree here, and then under the selector, we can go ahead and right click, and under add service, we're going to select on run EQS. This is going to allow us to run our query while it's also running the main patrol behavior tree. And this is the reason why that we wanted to make sure to set it into its own tree, so this way while it's running this, it can also run the EQS that we tell it to. Now what we want to do is duplicate this, so we have two different EQSs being run while we're doing our patrol behavior. First one here, we're just going to go to the drop down and click on the hearing. Second one, we're going to do the same thing, but we're going to click on sight this time. Now, as you can see, if you look on the details panel, it's looking for a Blackboard key to be able to set the value for something. Now, we need to make these Blackboard keys now, so this way you can actually have information to set and then act accordingly based off of that information. So what we're going to do is we're going to go to the Blackboard, go up to New Key, and the first thing we're going to make is going to be a vector key. And this is going to be the sense location. So this is going to be where it determines that it's either seen or heard something and setting that location for whatever it sensed. Now, we also want to make sure that we have a player value as well, so we can have some sort of an actor-object reference. So we can go New Key, and then under Object, we'll type in Player as the name, and then we're going to go to the key type under the Blackboard Details panel, and then under Base Class, change it from Object to Actor. This way, the top option here, Actor Type, and this way it'll be able to set it to the proper type. So we can just go ahead and save that, and go back to our behavior tree. Now what we're going to do on the hearing perception, we're going to change the Blackboard key to sense location, but we're going to change the sight perception to player. So if we are seen, it's going to set player. However, if we're just heard, it's going to set sense location. So now what we're going to do is we're going to start making another branch that we can use now that we've set it so if we are seen or heard, something can happen as a result of this. So off of the selector here, I'm going to run another selector. And this one I'm going to put off to the side here just like this, and I'm going to right click, add decorator, and this time what we're going to do is we're going to use a Blackboard condition. A Blackboard condition is essentially a Boolean value, more or less. However, it is a little bit more open to interpretation, more realistically. So, and what I mean by that is if we go to the Blackboard key here, and we go sense location is set. Even though technically speaking, a vector value isn't a Boolean, if it's set, meaning that there is information listed under the sense location Blackboard key, it'll allow this to be able to transfer over and run this branch. However, we want to make sure that it transfers over and runs it immediately, so this is what we can do under the flow control section. We can go observer aborts both. So this way, if sense location is true, it's going to abort lower priority as an option here, and it's also going to abort itself if it's not true. So this way, both will allow us nice flow control. Now, one thing I also like to do is duplicate this and drag this over to the selector that's running our behavior tree and just basically reverse this. So if sense location instead of is set, put is not set. Now from this selector here, what we're going to do is we're going to drag down and we're going to run a sequence. Now we're going to do a few things off of this sequence. So if sense location is set, we want to have him rotate to face. Now for those of you who are maybe a little confused as to how I'm doing the tasks here, if you drag off, go to tasks, you'll have a list here. You'll also have your list of composites. However, if you know what you're looking for, if you just drag off, you can, for example, the next node that we're going to need is play animation. So if I just drag off and type in play animation, it'll show up as an available task option. So I can just do this instead of actually having to go through and look through the tasks list manually. So what we're going to do is we're going to have it rotate to face the Blackboard entry. We'll set that Blackboard entry to sense location. This way it'll rotate to face the sense location, and we'll have it play a little reacting animation. This way it'll kind of give it some life, so when it hears something, it'll actually do something. Now once it reacts, something I like to do is put a little wait, and this is for a buffer. This is not necessarily for while you're developing, but more so after you've packaged your game, as everything is going to run a lot faster once packaged. So we're going to set that wait to 0.5, and then we're going to set a move to. Now the move to we want to set under the Blackboard condition. We want to make sure that Blackboard key is set to sense location because we're giving it a sense location information over here, so we wanted to have it move to that sense location. Now once it's at that location, we're going to run a wait. Basically just kind of like he's going to be sitting there and waiting for you to come back, and if you don't come back, we'll run EQS query. So we're going to pull off of this and click on run EQS query. So basically what we're doing is we're running EQS queries over here that are going to be by default running all the time while we're running our patrol behavior. However, we can also call EQS queries to specifically set values and information at a certain point within our behavior tree. So what we can do is we can actually just go hearing perception EQS, Blackboard key to sense location. Because what'll happen is that if as long as there is no sound being constantly played whenever this is run, it's going to immediately set the sense location back to invalid and run back over to the patrol behavior tree. So essentially, this branch is our investigation, so we can take this sequence and rename it to investigate sound. So what we'll do is now we'll give it a sound to be able to actually investigate. So what we're going to do is we're going to go to the third person blueprints BP third person character and pull up the event graph. And we're going to create a quick code just to basically create a noise event. So we're going to right click and go keyboard event E. And then off of pressed, we're going to play sound at location. After we play the sound at location, we're going to report noise event. So the report events are actually necessary for when you're using an AI sense component. So what we're going to do is we're going to get actor location. So this way it'll get the actor location for our third person character. And we're going to plug this into the location for the play location or play sound at location. And we're also going to plug this into the noise location for the report noise event. Now for instigator, just drag off, type in self, and get reference to self. And then the loudness, I like to choose around 650 when I'm testing, but you can choose a lower or smaller value depending on the area that you're working with. I always like setting a higher value while I'm testing and then just fine tune it later. And then we just got to pick a quick sound, so I'll just go ahead and choose explosion 1. We'll compile and save. And now if I go and pull up the behavior tree here, just so you guys can see what's going to be happening. If I hit save and then play, as you can see, he's running his standard patrol behavior. However, if I hit E and run and make it so that way he's actually going to react, so we got the reacting animation, wait, moving to the sense location, and then he's going to wait for about 5 seconds. Once those 5 seconds are up, he's going to rerun the EQS query, realizing that there's no sound available, and go right back into his patrol behavior. So right now what we've basically created is the ability for him to investigate a sound disturbance and reset himself manually. So now let's talk about if we wanted to make it so we could see the player and investigate the sound and use this for while we're in combat or not in combat. How would we go about doing that? Well, it's quite easy actually, and that's why we set the investigate sound to off of a selector, because technically speaking, this is going to be combat/investigate. So what we're going to do is we're going to take both of these queries, we're going to duplicate them. So we're going to click on one and duplicate it. So we got sense location here. And then we're going to do the same thing for the player and run it here. And what this is going to mean is that it's going to run both of these and make it so that way we can, just like over here while it's running the patrol behavior, it's going to run over here and check all of the information. However, there's one thing that we don't want it to do, and that's going to be to update Blackboard on fail. And the reason why is because if it updates the Blackboard on fail, whenever there's not a stimulation, so after 1 second, it's immediately going to undo the information for when it comes to the sense location. By unchecking this, we now just have that hearing perception sense location being unset by the time that it goes and investigates everything else. So what I can do is off of this, the combat investigate selector, I can pull off of it, run another selector, and this time what I'm going to do is I'm going to right click, add decorator, and we're going to choose that Blackboard base condition again. But what we're going to do is we're going to set it to is if player is set. And then we're also going to right click, add decorator, and we're going to run a conditional loop on this. So what a conditional loop is it allows you to be able to run and execute a specific branch over and over and over again, so long as whatever condition that's holding it there is true. So in other words, we want to make sure this is looped if player is set. Because now what we'll do is we'll minimize and we'll create our combat behavior tree, but we're not actually going to do it in this video. That's going to be the next video where we start setting up the combat portion of the AI. But what we can do is quickly create the behavior tree so this way it's ready for us. So we can right click, go to artificial intelligence and behavior tree and type in combat main BT. Now the reason why we go combat main BT is because we're going to actually create a different subsection of behaviors for range combat and melee combat that are going to be determined within this tree itself. But we want to make sure that we have something in here. So we're going to go off of the root, run a selector, and then off of the selector, we'll just run a simple wait task. Now we can save this, go back to our main behavior tree, under the selector, we'll pull off of this, and we'll run behavior. So we'll click on this one right here. Now the behavior that it's going to be running is going to be the combat main behavior tree. So again, just to give you an idea of what we're doing so far is that we're running a regular patrol behavior pattern. However, if we hear something, we're setting the sense location. If we see something, we're setting the player. Now, the only thing we need to do now is if our player is seen to also make sure that we're setting the sense location. So what we're going to do is we're going to take the sight perception EQS on the patrol behavior, we're going to duplicate it, and then this time, instead of if we're seen, we're going to go ahead, instead of setting the value of player, we're going to set it to sense location. So this way it's going to set sense location and player if we are spotted. So if we go ahead and hit save, and we just minimize this really quickly, I can go ahead and actually, you know what, I'll go ahead and bring up the behavior tree so you guys can see the flow. And what you'll see is that now the AI is going to reset itself accordingly based off of, you know, however long we're in view. So as you can see, now he sees me, we're playing the animation. Okay, so we didn't set one thing though. So under the player is set Blackboard condition, we need to make sure observer aborts both. So this way, so long as it is true, it's going to shoot right over. However, if it's not true, well, then we're going to want to double check. So we'll go ahead and just take this back down a little bit. Now, so if I go ahead and hit play, you'll see immediately he goes right into player is set. Now you can add a wait function if the rotate to face and play animation is a little too heavy. So we can go ahead and just kind of like move some of this around a little bit, move the wait task, the animation, rotate to face, and then just run a wait task of 0.5 seconds, click on save, and then we can go ahead and we'll remove that issue. Because as you can see, now he's going right into the combat tree. However, if I can get around him, here, I'm going to go ahead and move the player start here. So if I go ahead and hit play now, I'm not in view. He's running his patrol, but I'm going to run and make a sound. He's going to rotate to face, play the animation, and then move to the sense location. However, if I get in view, immediately he's going to run over and see that I'm there and run the combat tree. However, if I run out of view, he's going to run the reacting animation, and then move to the sense location again. And he's going to basically go back and reset himself, because that's just like what we had before. So long as there's nothing being run on the hearing EQS, he's just going to go ahead and be right back to patrol. So there we go. Now we have a fully functioning perception system within our AI. In the next video, we're going to look at creating the basic combat setup, as well as how to be able to create sockets and some things to keep in mind when creating your animation blueprints and adding in combat sections. So I hope you guys enjoyed today's video, and as always, stay animated.